Okay, good. Good morning. Beautiful Sunday here at Los Baños, and here I am. I'm streaming this session of Kerbal Space Program. It's been a while since I last Kerbal, so I'm just going to do something really simple, um, something more introductory, I guess, for people who are not yet familiar with this uh, game. Uh, it's actually an educational game or educational toy. Kerbal Space Program is a game wherein the objective is to achieve spaceflight. And not only spaceflight, but also atmospheric flight. Um, it does this by simulating the physics that we have in this universe that we inhabit. But the catch is we are not simulating or we are not depicting human beings, but instead we have these cute green aliens. These are very small creatures. Probably their size is something like a tenth of human size, I think, because all of the planets, even their star, their sun, which actually they also call the sun, but another term for the Kerbal Space Program universe's sun is Kerbal. So this is the start menu of Kerbal Space Program. So even though everything seems to be miniaturized, it still follows the laws of physics that we know of in this universe. Newtonian physics in particular, because most of the stuff happening in Kerbal Space Program is sublight speeds. Although there are modifications to the game that have been made by other users that actually try and mimic near light speed travel, speed. It's not really an accurate simulation. It's more like warping from point A to point B. But if we were to simulate sublight speeds, I mean significantly lower than light speed, maybe in the neighborhood of hundreds of thousands of kilometers per hour. Kerbal Space Program handles that quite well, Newtonian physics. You might say that game must be really difficult to play because of the fact that space is huge, right? And it requires an enormous amount of time to traverse such distances. A good thing is simulations such as these have you have the option to actually speed up the time. That means we can actually make time, as we know it, move twice, 3 times, or even higher at higher speeds, so that we can actually traverse large distances in this space, in the near space, the interplanetary space of Kerbal, quite fast. Because yes, even though this is a miniaturized solar system, it would still take like years of human years in order for these Kerbals to actually reach a neighboring planet, even their closest planet, from their world. What you're seeing right now in the background is some planet that looks much like the Earth, in the sense that if you can see, there's water represented by that blue color, and the green and brown parts. If you are a keen observer, you might also notice that their planet actually has no clouds. That actually is telling us that there's no weather in this planet. When I say no weather, it means that there's not much wind, there's no storms. And I think the authors of the game did that to basically just simplify matters, in the sense that it's much more complex to launch rockets when you have issues like weather. In fact, if you may have noticed when you try, when you watch launches in NASA TV or any other launches from the European Space Agency or the Russian Space Agency, sometimes the launches are put on hold if the weather is not agreeable or there is adverse weather. But in Kerbal Space Program, of course, there is a lack of weather, so rocket launches will be easier. Because one objective of this game, aside from entertainment, of course, is just like what I have been promoting or campaigning for, especially during my time with this company, is of course edutainment, meaning utilizing entertainment programs such as Kerbal Space Program and programs like Celestia and Stellarium, which are actually free. Kerbal Space Program, by the way, is a commercial product. You have to buy it in order to actually try it out or play it. And there is actually an educational version. So what's the difference between this version, the one that you're seeing right now, Kerbal Space Program, and the educational version? Actually, they're identical, save for the fact that the educational version of Kerbal actually comes with education modules. There are actually lessons in physics that are embedded into the program so that the user can actually load those lessons and then simulate the principles by actually launching a simulation of the problem. Because of course, when we talk about physics, we usually talk about trying to solve problems, right? Like trying to figure out what is the necessary thrust in order to lift a certain mass up into the sky, or how do you get this amount of mass to orbit a particular planet or particular celestial body. So those before in the olden days, it's all manual computation. You need to like really solve equations in order to get the answer. Well, we still do it right now, of course, but it's so rewarding, and actually it helps encourage kids to appreciate the problem solving better if they can actually visualize the solution. That's why Kerbal is very good at that. For instance, if you have a problem like that, like you want to see how much thrust you need in order to boost a rocket or its payload, a satellite, up into orbit, you can do the calculations on paper, but then you can use those same values, the same data, plug it into the rocket you're building in Kerbal, and see if your resulting equations are actually, it follows your prediction based on your calculations. So without further ado, let's try and enter this program, and I will try to build a very simple rocket and talk about simple concepts in rocketry. From a layman's perspective, I will try my best, and in fact I don't really have to try because I'm not really good at math, so don't worry, I won't be bringing up complex rocket equations for us to deliberate upon. But who knows, maybe I can just get some simple simple equations, something as simple as the computation, for instance, for speed, which is distance over time, right? So such simple things we might need to look into while we're doing, or while we're building our rockets. So without further ado, again, I'm going to jump into Kerbal Space Program. Okay, so we're going to start a game. These are the Kerbals, and they are in orbit. I don't know why they're floating out there in space. It's just a cute cover. This is actually a female Kerbal. She's named after the Russian cosmonaut Valentina Tereshkova. Okay, and we're going to start a new game. Now, looking at the screen, if you notice, there are several game modes in Kerbal Space Program. So there is career mode, there's science mode, and there's sandbox. So what's the difference between these three options? Sandbox means just like a sandbox. I don't know if kids nowadays actually in their schools, especially younger kids, if they have sandboxes. A sandbox is basically a box full of sand, which is sort of a place where kids can actually be tactile with sand, and shape the sand to whatever they like. They can actually, especially if you have toys like the construction vehicles, it's nice to play those vehicles in a sandbox so that the kid can pretend that there's a bulldozer pushing earth or sand, and or maybe a payloader scooping up the sand and placing it in a small dump truck. That's what happens in a sandbox. So when we talk about a sandbox in Kerbal Space Program, it means that we're free to access most of the tools in Kerbal Space Program, and just be a free for all test and experimentation, and you have access to all the tools. What about career mode? Career mode is more of a game mode. Basically, you are tasked to set up a space agency, or actually the space agency is already set up. You're just given a budget, and you must try to get these Kerbals out into space. And you get rewarded for certain achievements like achieving orbit, or launching a satellite, or reaching the closest celestial body from Kerbin. So it's just like, how the US space program and the Russian space program happened in the 1960s. In the career mode of KSP, or Kerbal Space Program, there's no competition. There's only the Kerbals. They're just trying to get out there into space. It would have been fun if the authors of this game actually made it more like a competition, like there's another race on this planet trying to achieve, or another nation trying to achieve space. Because as we learned in our history, in human history, it seems as if we get to do innovations, or scientific innovations are accelerated if people are in competition. Just like what happened during the space race between the United States and Soviet Russia, when they were competing and they were trying to, top each other off. They were trying to see who was the best in trying to get into space. So career mode in Kerbal sort of simulates that, but there's not much competition. But the rewards are really nice, because once you get all these rewards, you get more money, so you can actually even play the role of a manager, wherein you can actually manage the finances on what part of the program are you going to build up. Like, are you going to invest more on safety, or will you risk less safety but more on putting the minds, because you're going to hire like scientists, and you're going to like invest in trying to find new technology for propulsion. So if you want to take risks and you want to focus more on propulsion, you can also do that. But then, of course, your rockets might keep exploding because you did not invest heavily on safety. You can also be like a more on the more financial side. You can actually also embark on campaigns to like promote the space program and so on. Yeah, you can actually do that. There's a segment there, or there's a portion of the management wherein you can actually do like promotion. You can even like do cutbacks on the salaries of the scientists, and you know what will happen? Of course, they're not going to be happy about it, so they're going to make some mistakes probably, and therefore your engines might not be 100% reliable, so they might blow up. But then if you can actually do a great balance, like in saving this from the salary of the scientists, and then investing the money that you saved heavily in other aspects, like improving your launch pad, that can also be a plus. So it's really a complex game if you think about it, especially if you go into career mode, and it's really fun. What about science? Science is similar to career mode, but the focus is on the science that you will gather while you are performing your while you're performing your launches. So funds and reputation are disabled, because in career mode there's money and reputation, meaning if you keep failing your missions, your reputation will go down, so your funding will also decrease. But in science mode, those are disabled, so that you can just try and do science without having to worry about the financial side of things. Some of you who are into scientific research might love that, right? Unlimited funding. So these are the three modes. So what am I going to select? I'm going to select, so I'm going to name this the live stream game. So I'm going to select sandbox because we're just here, a simple session. We're just going to try and figure out how rockets launch, right? It's a very simple difficulty normal. Okay, let's start. Just a very simple session. So the game is loading up right now. And the thing about Kerbal is, okay, so this is the screen when you first begin. There's a guy named Gene Kerman welcoming you to the Space Center. So this is our version of KSC, which is the Kennedy Space Center. But of course, now it's the Kerbal Space Center, the KSC. So this is Gene Kerman. If you're familiar with the name Gene, it's because there was a famous flight controller in the NASA program in the 60s, Gene Kranz. If you have seen the movie Apollo 13, he was played by Ed Harris, unforgettable character. He is in that crew cut wearing a vest in mission control, and he's directing all of the operations of the Apollo missions. No, so Gene Kerman represents Gene Kranz. So he's actually giving us some pointers for the first-time user. So what are these buildings here? So this is the research and development. Like I said, this area here has all the scientists trying to, all the in career mode, this is important because when you get data from out there in space and bring it back here on Earth, the research and development area will be the one to process all that data and give you improvements like, oh, they found out that engines perform better at certain altitudes, so they will give you an engine that will probably evolve eventually into a scramjet engine, a jet engine that works in higher altitudes better, right? So it's really nice. This is the research and development. This is the astronaut complex because this is where you hire Kerbals. Because unfortunately, of course, space is hard. It's a risky business. Sometimes Kerbals indeed die. When you launch a rocket and it fails and it's occupied, it's a manned mission, and it crashes, the Kerbal will die. So you need to go every once in a while to the astronaut complex to hire more willing Kerbals to join your space program. This is a space plane hangar because KSP, as I said, is an aerospace simulator. It's an aerospace game. So you don't only deal with spaceships. You also deal with aircraft or high altitude aircraft. Still within the atmosphere, but almost close to the edge of space. So you can actually develop stuff similar to the SR-71, the X-15, or even the XB-70 Valkyrie, and maybe some other exotic aircraft you might have in mind. Here is the tracking station. This is basically a radar network that tracks your craft while it orbits Kerbin, or maybe if it's en route into another celestial body. Now, it's important to note that Kerbal actually simulates a DSN. Are you familiar with the acronym? DSN stands for Deep Space Network. What this means is if you are sending a probe or a manned mission to another planet, it's important to establish first a good communications relay network. Otherwise, that mission will be flying out into that other planet without any communication support. So it would be difficult to send data back and forth and guide the Kerbals to their destination. So you also do launches for that, meaning you actually have to launch communication relay satellites and place them in an appropriate orbit in order to create that relay. So it's really engaging. It really reflects how complex space operations are, right? So you have a tracking station. This is the mission control station. This is where, of course, all the mission management occurs while the mission is ongoing. And this is, of course, the VAB. It looks just like, see, you can actually rotate around this area. It looks like the vehicle assembly building down there in Cape Canaveral, right? So this is where the rockets are built, the big building, and you can see a ramp. The ramp here, this sort of track leads from the VAB to the launch pad. Of course, the launch pad is where the rockets are being launched. This is the spaceplane hangar. That's why right beside it is a runway, so that you can. That's where you actually fly your what's this? Your aerospace vehicles. So in career mode, this whole area is actually very bare. It's almost like just, you know, a patch of farmland with some very simple buildings in it, because that's also how the real NASA started, right? They started out, you know, like National Aeronautics. It was NACA before it became NASA. I just forgot what NACA stands for, which is embarrassing because I actually knew what NACA was. I just keep on forgetting. Memory loss na. So what's this? So in the early part of the career program, this area is very bare because you don't yet have a communications relay set up. There's no tracking station yet. The R&D building is just a simple building, maybe a small shack where you do, you know, DIY projects. And yeah, everything is simplified. Your launch pad in the early stages of career mode is actually just the... Maybe I'll show that later, no? Maybe I can show that later. But right now, without further ado, let's enter the vehicle assembly building because we're about to build our simple rocket. So now the VAB, or the vehicle assembly building, is loading up. Oh, look at this. We're now welcomed by a guy, this Kerbal named Werner von Kerman. Again, it's he is meant to represent the great Werner von Braun, the German scientist who joined NASA and helped NASA achieve its objectives during the 1960s and 1970s space race. The culmination of which was the Apollo program, which actually let humans step on the surface of the moon. So Werner von Kerman is welcoming us. He has many tips. So thank you, Dr. Werner von Kerman. So on the left side of the screen, you see the many tools that we have in order to build a rocket. They are categorized into pods, which are these objects. These are the actual modules that go out into space. Either manned, in the case of manned program, you have capsules. In unmanned programs, you have the probes. So here are the different probes. Look at the funny names. Probe, they're tongue twisters. Probodobodine, Heck 5, that's one of the probes. Yeah, Probodobodine. Then you also have, this one is similar to the Mercury programs. Was this capsules? This one is a 3-man capsule, which is quite similar to the Apollo program capsules, which also is occupied by 3 astronauts or controlled by 3 astronauts. And underneath the pod, you have the fuel tanks. So lots of fuel tanks here for your different needs. Underneath that is engines. So here is the heart of the rocket. This is the power plant. This is what makes the rocket go. But of course, it has to work hand in hand with the fuel tank so that it supplies fuel to the engines. So there's so many kinds of engines of different sizes. Then you have command and control. So these are some augmentations to control. So you actually have some basic control, or it gets on to more complex means to control the spacecraft while it's on ascent. And once it reaches orbit, you need reaction control systems in order to, you know, orient the spacecraft in a particular orientation. Structural. These are parts which help you build up your ship. Fuselage parts, or maybe if your objective is to actually create a space station, there are parts here like trusses wherein you can utilize in order to build that station up in Kerbal orbit. You have couplings. Couplings are these they are joints that actually, you know, make rockets couple. That's why it's called decoupler, because it decouples. Like when you are building a rocket, you have to build it in stages, and the reason behind it is you will see it right now when we build our rocket. Okay, so these are the decouplers which let rocket stages be attached to one another. This is a payload system wherein you can have fairings, because if your satellite is of an odd shape and it's sitting on top of the rocket, it's not very aerodynamic, right? So you need to place a fairing in order to make sure that your rocket is streamlined, so that while it's exiting the atmosphere, your probe will not disintegrate or will not, crumble into pieces while it's trying to ascend through a very thick atmosphere. So these are fairings. Then you also have, if you're building something similar to the space shuttle, you can have like a section of fuselage wherein you can put cargo, and it actually opens up so that it opens up and it can release a satellite or whatever payload you have. Here are service bays wherein you can actually place scientific instruments to be protected from the exposure to space. Here is the aerodynamic button, and you will have access to many kinds of wings and control surfaces, which will enable air vehicles to actually fly in the atmosphere of Kerbin. So for those who like airplanes, this is a very nice section, because you can actually build something similar, quite similar to aircraft that you might be quite familiar with here on Earth. Here is landing legs and wheels. Of course, if we want to build a vehicle that can actually land, you need wheels or struts, landing legs. So here are for the type of capsules that would land on other worlds, but the wheels are intended for aircraft that actually would land on a runway. Here they are. These wheels, on the other hand, on the bottom, are for rovers. If you want to bring a rover to another world in Kerbin, you can actually do that, make it into a payload. Then once the lander reaches the planet, you can actually release another section of the probe wherein it actually has wheels, and you can actually move around. Thermal. These are items that protect spacecraft that are entering a celestial body that has an atmosphere, just like the Earth, or in this case Kerbin. When you re-enter, of course you need to be protected, because your craft will burn up like a meteor upon re-entry. Here is the electrical section wherein you need some sort of power supply, right? Electrical power to supply your ship. So it comes in many forms. You can have fuel cells, which are powered by hydrogen fuel cells. You can also have solar panels, wherein the Kerbin sun, or Kerbal, can actually provide power to your batteries via these solar panels. And of course, my favorite, and of course many people might disagree, it's a very risky and hazardous device. It's the RTG. It's a radioisotope thermoelectric generator. If you have seen the movie The Martian, this device was the one that Matt Damon's character, I forgot his name. My memory is really bad now. What was his name? The guy from The Martian. Anyway, Matt Damon's character, he had trouble with this thing because if he places it in the rover becomes too hot, right? So he had to take off his clothes, and he had to dispose of it properly by returning it back to the hole where they dug, in order to make sure that it doesn't contaminate the base and the rest of the crew, because it's radioactive. This is basically a small nuclear reactor that provides power to a spaceship, or to a lander, or to a rover. And here are some battery packs. Here is what I said earlier, the different communication antennas that you can use, antennae that you can actually use to create that relay, communications relay network, like a DSN. And here is the science section. These are the different scientific instruments that you can use to gather data from out there in space, and use the science that you collect in order to impress. Now this is in career mode. You will impress your your employers, and thus they will give you more funding to create more rockets to explore further into the Kerbin universe. So you have things like thermometers, barometric pressure, measurement devices. You even have seismometers, because when you land on a certain world, maybe there are some, planet quakes on that world, and you can actually like measure seismic activity. So lots of nice and neat instruments. At this point, I want to tell you guys that we're actually running Kerbal Space Program without any modifications. This is stock. That's the term we use when we're running a game or a program without any modifications. It's stock mode. But look at the rich amount of stuff that's already in here, and it's not even modified yet, or modded. That's the term we usually use when we modify a game, modded. So a modded Kerbal Space Program might have more stuff here, like more scientific instruments, more utility instruments. So among the utility instruments includes a launch escape system. This attaches to the capsule on top of the rocket, so that in an event of a catastrophic failure of the lifter or the boosters, we can save our astronauts by activating the launch escape system, and it's going to pull out the capsule and so that it can parachute to safety. So the Apollo program had that. The only rocket that NASA ever had, manned rocket, that did not have a launch escape system was the Gemini rocket, because it actually was more of like an aircraft. That capsule actually had ejection seats, so the pilots can actually eject from the Gemini capsule. Okay, and here is a very interesting. Here are very interesting devices. These are actually processors. They process minerals. They are utilized for the so-called getting the terms, in situ gathering of rocket fuel. The raw materials for making rocket fuel, they can gather it from the moon, or in this case, the moon. That's the equivalent of our moon in Kerbal Space Program. When you reach the moon in Kerbal Space Program, you can actually bring along a device like this and gather the soil from that place and convert it into something that could be used as rocket fuel. So this kind of device, we hope to have it in future spacecraft, in the real world, so that we don't have to depend on the Earth for rocket fuel, because that's the reason why rockets can be an expensive prospect, because in order to build a rocket, you must have fuel to reach your destination, and also enough fuel to go back, if you want to go back, right? But if you have just like this, you can actually process local material in that target world and create rocket fuel, so that when you go to that place, you don't have to bring a lot of fuel. You can just bring fuel enough for the trip to that target planet, then process the materials you have on that planet, make it into fuel, and you can load that on your ship and go back to your home world. So it's really nice. So here, I think I've already given you a good overview of these buttons and what they do. So let's begin building our rocket. So obviously the first thing that we need if we're going to do a manned program is a place, or a structure wherein the astronaut will be in, or he will be occupying. So let's get this MK1 command pod. There it is. So it's similar to the Mercury program capsule. So inside is where the astronaut, the Kerbal, will sit. Even though that looks like a heat shield, this actually doesn't have a heat shield yet. So maybe the first thing I can do is go to thermal and try to add a small heat shield underneath, so that it can, well, something's weird here. Maybe I can do some adjustments, because you can actually adjust portions of that. Yeah, there. That looks like a proper heat shield. Yeah, there. And then now we're going to add a battery. Where is electrical? Let's add a small battery on top. Oh, that's too big. So that you can power our electricals. And of course, so that our Kerbin can go back to Earth safely, we need a parachute, a small parachute on top. So there, this finishes a very basic capsule that will safely get back to Earth once it reaches a certain altitude. So we're just gonna test. A simple rocket would require a fuel tank. Let's just get a very simple fuel tank, maybe just a tiny one, just to demonstrate the principles of rocketry. This is a very small basic fuel tank. But before I have to place it here, I have to find a way for the fuel tank to separate with the capsule, because right now this is just one piece. So that's where the decouplers come in. So we get the decoupler and get this decoupler and stick it there. Okay. Now we need an engine. So let's select an engine that would fit nicely underneath our rocket. Maybe this one. Look, that's cute. Let's examine the details of this engine. So this engine is the Terrier, and this is the amount of thrust it has, 19 kilonewtons. Okay. So our craft now has 7 parts. Its mass is 3.3 tons. So is 3.3 tons, is this amount of thrust enough to lift this? We will find out. This is our very simple rocket, and we can actually launch it at this point and see what happens. You want to launch it now? First, we're going to name our rocket. 1. That's the name of our rocket, and we're going to save it. So let's launch it. Let's see what happens. It's now bringing our rocket to the launch pad. So the next scene you'll see is, oh, look at that. Here's the launch pad, and our rocket looks so tiny compared to the size of our launch pad, because of course our launch pad can accommodate really huge rockets. Okay, so it's a good thing our rocket is symmetric, because it's actually now just standing on its engine, which is not the ideal way to launch a rocket, because in the real world this is really bad, because the nozzle of the rocket is being blocked by this grating. Although the grating is supposedly parts of it is it allows rocket exhaust to go through, but just to show you how a rocket should be properly mounted, it has a kind of clamp mechanism. So we're going to escape and revert back to the vehicle assembly building and add some kind of release mechanism for our rocket. So in order to have that, we're going to find structural, and here is a launch stabilizing enhancer thingy. It looks disproportionately large compared to the rocket itself, but that no worries. And it's too high now, so we're going to lower it down like that. Oh, look at those cute Kerbals. The Kerbal engineers are examining. Oh, he went through it. Okay. So here's our launch clamp, and it's holding on to the rocket. So, the sequence of launching should be this engine should ignite first before we release, right? Because if we in the order, this is actually on the right side of the screen, shows you the staging or the order of execution of events. So look, by default it says here that the first thing to be activated is the clamp, and I guess you know what will happen first, right? If the clamp, I can demonstrate that when we go to the launch pad, but right now let's do it the proper way. First you ignite the engine, and then you release the clamp, and then when our rocket reaches a sufficient altitude, we're going to separate the capsule from the rest of the rocket, and then parachute to safety. So that's the sequence of events here on the right side. You activate each sequence via pressing the space bar. So let's launch. Let's see if our rocket, what altitude can this simple rocket can reach up into the Kerbin sky. Okay, here. So as you can see, notice that the clamp is actually at an angle now because, of course, our rocket has mass. The fuel inside this rocket, look at that, that's the fuel and oxidizer. It has weight, and therefore it's pulling down on the arm. That's why you can see there's a slight inclination towards the left side of the screen over here. So here is our clamp, but it will be offset because once we activate this engine, it's going to create thrust, and at the moment of release, hopefully the rocket will not fly in this direction, but we will see. So in the upper right hand corner is a way for me to monitor the electric charge, the oxidizer, liquid fuel, ablator, which is the heat shield, and the monopropellant, which we're not actually using right now, which is a means to control the capsule when it's in orbit. But we're not actually going to reach orbit right now because obviously we have a small fuel tank and a very modest rocket engine. So we're going to launch it right now. So a space bar when I launch it. Thrust is at 100%, so I expect the thrust to... Uh-oh, looks like our rocket is really weak. Let's see what happens when I release the clamp. Boink. Oh, it seems our 15 Newton engine is not enough for our rocket to actually take off. See? So that alone gives you an idea of if you don't really calculate that initially, you're gonna fail. Okay, so let's revert back to the vehicle assembly building and find a stronger engine or an engine with more thrust, because we're dealing with 3+ tons here. So let's find an engine that's more suitable. I guess this kind of engine is 251 kilonewtons. See that? That should be enough, right? Compared to 15 here. It's longer than the other engine, but look, the detailing is really nice. I like how the 3D modeler actually incorporated, you know, the different pipes. These pipes go into the oxidizer, and you can even see it. This might be the oxidizer tank, and this might be the propellant tank. Oxidizer is actually liquid oxygen. It actually provides oxygen to the flame so that there will be more thrust. So rocket engines need that because when the rocket reaches space, there's no more air. So there's no combustion if you don't have air. So liquid oxygen is the substance used to do that. Okie dokie. So we're now going to, I think this okay, we have the engine, then release the clamp, decoupler, and parachute. Okay, are we ready? Okay, Kerbal engineers, I'm going to launch our, save it and launch. We might have issues with our center of gravity, but we'll find out what's gonna happen. Okay, so anyone want to make a bet? Will this fly? Oh look, there's the moon in the background over there in the sky. Okay, crossing our fingers. Oh, that's a good thrust. Release. Wow, look at our rocket go. It's now flying up. There's even the shadow over there. Oh, look at that. There's oh, whoa. You know why that happened? Because we don't really have any control on the rocket. It's still going upwards, by the way. Look at that. It's actually gaining altitude still. But our fuel is already depleted. There's no more fuel and there's no more oxidizer. Let's wait until it reaches so-called apogee, which is the highest point in its parabolic path through the air. Uh-oh. And now I think it's about to fall. It's still gaining altitude, but there. It has reached apogee and it's falling. It's time to decouple. Okay, so there's the engine. It's heavier, so it's going downward faster a bit. And here is our capsule, and it's hurtling back down into the ground. The speed is building up. The speed is here, surface, in the artificial horizon. 190, it's really gaining really fast speed. Look at Jebediah Kerman. He's smiling even though he's not yet sure if the parachute will work. Once it reaches 1,000, or here, we're going to release the chute. And hopefully at a certain point it's going to blossom. There. There. And there is our parachute, and you can see the shadow. And here's the impact point of the stage, the first stage earlier. It actually impacted, and it survived the impact for some reason. Usually that explodes it. So here comes the shadow. And here is Jebediah Kerman smiling because he's safe and sound so far. We don't know yet what will happen when the capsule is descending at a rate of 5.9 meters per second. That's still quite hard when you feel that on your body when the capsule bang impacts on the ground there. That's why in the Soyuz vehicles, right before they actually touch the ground, they will fire rocket engines so that it will slow down the pod to a significant degree so that the astronauts won't feel the impact of actually hitting the surface of the ground. That happens for a split second, and if you watch the Soyuz landing videos when the Soyuz capsule parachute, you will notice that a split second before it makes contact with the ground. But we didn't have such a system. But our Kerbals are very, they're quite. Okay, excuse me for a minute. Someone needs assistance. Just enjoy. I'm going to bring out Jebediah so that you can see him there to entertain you a bit. Okay, so you can actually control the wait. You can actually control the individual Kerbins once they have arrived. This is nice to simulate what they do when they arrive on another planet or another celestial body, another satellite, because they can do operations like, look at this. They can actually take surface samples and transmit the data from those samples, or just keep the experiment in their spacesuits and transfer it later into the ship when they get back. There. So we just did a fairly simple test of our capsule. Let's go back to the vehicle assembly building. So I hope you're enjoying this so far. At least you're learning something about Kerbal Space Program. Debris here, so we're going to pick that up, recover that debris. So now, my last attempt. Maybe I'm going to do another session of this because actually I'm running out of time right now. But I'm going to try and reach orbit. So I can also demonstrate a principle of rocketry that many people have this question about the rockets, because if you look at the structure of a rocket, what we did was a rather simple rocket. There's an engine and there's a fuel tank. But why is it, people often ask this, why is it that rockets seem to require many engines, like staging? Why is staging necessary? Well, of course, in order to reach space, you must first escape the atmosphere. And you cannot do that, or it's very difficult to do that with just one engine, one stage. Because imagine, you need to bring all of that fuel there with you as the rocket ascends up into space, right? So, the concept of staging was introduced by the early rocketeers in order for the rocket to save on weight, because when a certain stage expends all its fuel, then you discard everything, including the engine and the fuel tank, so that the entire rocket will be lighter. And when it's lighter, the next engine in the stage will now be pushing a lighter overall craft up into space. So that's what we're going to do right now. We're going to build stages for this rocket. I'm still going to use my core rocket, but this time we are going to add stages. So first is I'm going to add a decoupler here. This represents the first stage, and we're going to add, I think I'm going to go to structural and then utilize this part and add a larger fuel tank. Let's pick a fuel tank like so. See, that's why rockets look more like this. So people are wondering, why is it that rockets look skinny up towards the top, but then it's kind of fat towards the bottom? It's of course because it's being built in stages. So look at this. I wonder if we can actually reach orbit with just 2 stages, with this guy and that guy. Maybe we can. But to be sure, maybe we can just add yet another fuel tank here, so that we'll have lots of fuel on ascent. So this would require, of course, a larger engine. Let's get a larger engine here. This one, this guy, I'm pretty sure, look at the amount of thrust. It's 1,379 kilonewtons. That's almost overkill, but then I just want to reach orbit for now and let you see what is required for a rocket to actually reach orbit around its home planet or the celestial body. Now, this obviously requires a means of controlling it, because as you saw earlier in our first launch, our suborbital launch, at a certain point the rocket suddenly lost control and it began to, you know, topple or go end over end. It's like doing a somersault. So in order to prevent that, we have to go to the aerodynamics tab and find a way to control our flight, our ascent. We're going to add fins. So let's try some simple fins like these fins. And I actually can add 4 of them to stabilize the rocket on ascent. This rocket actually can also gimbal, which means it's like a ball and socket joint. You can actually redirect thrust at a certain vector. So that also adds to the control mechanism for the rocket. But in order for the vectoring to work well, the gimbaling, we need a good guidance system. So here's command and control. And we're going to go back to this part of the ship, the second stage, and add maybe the advanced inline stabilizer and maybe a battery to actually power that. So the advanced inline stabilizer will help us with controlling the ascent, so that we won't, you know, go crazy while we're trying to achieve the ascent path in order to reach orbit well. So what else do I need? Just to demonstrate another aspect of command and control, we can add so-called RCS ports. What are these? These are engines that actually make that have let a rocket tilt or tip over or even rotate, but this needs a monopropellant tank. So we're going to add yet another fuel tank, but this time we need hypergolic fuel from a monopropellant tank. Okay, that would be okay. Okay, so I wonder if our rocket can actually reach Kerbin orbit now. So again, I'm going back to structural, and we're going to add clamps now. I think 4 clamps is overkill, but still it makes the rocket more stable like that. So again, engine will fire first before we release the clamps, and of course once this part of the fuel tank is expended, we need to decouple it, which is in this part. Then of course once it reaches orbit, we're going to decouple, and this engine will actually, if there's enough fuel actually here, I think we need to change the fuel tank here. I'm not confident that this fuel tank can actually you know, be enough to bring our craft into orbit. So let's try to make that larger. So our rocket is now slightly taller than before. Okay, looking good. Save it. So you want to launch it now and see if we can actually reach Kerbin Orbit. So let's launch it. So rocketry is possible because of Newton's third law. What is third law? Very can you recall your high school physics lessons? Newton's third law states that for every action, in this case the action of our rocket engine, there's an equal but opposite reaction. So there's an equal amount of force but on the opposite direction, which is the flight path of the rocket, where the rocket is pointed at. So that's why rockets launch, or rockets fly up into the air when it's ignited. So first, I'm going to activate the SAS, which is this module here, the one we attached that controls or stabilizes our ascent. Where is that? How do I? This part over here. So we activate it by clicking on that part of the artificial horizon. So let's do a countdown, simple countdown. Oh, this time our astronaut is Valentina Herman, the female astronaut. She's just gonna be the first one to space. Okay, so 5, 4, 2, 1, and launch. There goes our rocket. It's really ascending fast. Okay, so now I'm doing something called a gravity turn, which creates our ascent path. Look at that's the dynamic pressure on our ship. Oops, the ship is heating up because we are actually over 1,000 meters per second now. We're in danger of burning up. Check the map. Here is the map and we can see, oops, look at that. This is our ascent path up into space. And here is the apogee at around 131 meters. That's 131 kilometers up there. So, if we do nothing at this point, the rocket will simply reach the apogee and then go back down. That's called a suborbital hop, which is similar to what we did earlier. But this time, earlier we were in atmosphere, but right now, shortly, in just a few seconds from now, we're going to reach, quote-unquote, the limits of space in Kerbal. So I think it's 70,000 meters or 70 kilometers up. So in a few seconds from now, we have reached space. There, when the music begins, you know that the rocket is already in space. And now I'm going to turn on the RCS so that you can see how those tiny reaction thrusters help control the orientation of the ship. And speaking of orientation, once we reach apoapsis, we need to be oriented towards the direction of flight in order to circularize our orbit. So what is this thing about circularization? This is actually what needs to be done so that the rocket or the spacecraft will go around our target or our home world, Kerbin. A neat feature of Kerbal Space Program is you can actually plot maneuvers on the actual path of the rocket. So in this case, I'll add a maneuver node. It's quite complex if you don't know what they do, but it's simply dragging these points so that you can create a hypothetical or planned path of the rocket. See that? This means that if I exert that amount of thrust, this amount of thrust, then the shape of my orbit will turn from a parabolic one into one that actually wraps around the target planet here. So that will happen in about 1 minute from now. So we have to be ready so that in 1 minute we're going to fire our engines to begin the circularization burn so that we can actually orbit Kerbin. Okay, is our rocket nicely oriented in that direction? Okay, I'm going to orient it. Look at that blue spot there. That blue marker indicates that we need to point our rocket in that direction. Okay, there's just 33 seconds to go. Actually, we're going to divide this value, the 18-second burn, into 2, which means 9 seconds, which means when the countdown is around negative 9 seconds, that's the time that I'm going to initiate my burn. Okay, so here we go. 5, 4, 3, 2, 1, and okay, initiating the burn. And as you can see, look at that. Wow, look at that. We ran out of fuel, but no problem. We're going to stage and we're going to ignite our second stage, the process, because we ran out of fuel in the first stage. So see, that's why staging is necessary. And there we go. That's it. We have finally achieved orbit. And Valentina Kerman, it's a bit dark here so you don't see her, but she's really happy. She's now the first female Kerbin up here in Low-Kerbin Orbit. Okay, so let's make her go around once around the planet. I can speed up time in Kerbal Space Program, so you can see that it can actually, like, the capsule is going around Kerbin. And at this point, I'm going to do something, even though we haven't completed one orbit. I want to land my capsule near our space center. So how do I do that? I do a retrograde burn. So I'm going to point the rocket. Actually, it's now in a good position, I believe, for a retrograde burn. And we have enough fuel for that. So all I need to do is to burn my engine like this and watch until my perigee, this is not good. I should have done it in another point in my orbit, maybe here. Okay, so now I'm going to yeah, there. Still not good. Maybe here. Okay, then burn again. See the PE? So the PE is our perigee, and that means the lowest point. So I need to get that down so that it almost comes into contact with Kerbin. So hopefully we can land somewhere here, I think. We will find out. So since we are now getting closer to re-entering, at a certain point I need to decouple the capsule from the rest of the spacecraft because it's dangerous. This is still full of fuel, and when it re-enters the atmosphere, it might explode and actually damage our capsule or even kill our astronaut. So we're very close to deorbiting now, so I need to decouple it. So bye-bye to the other part of the capsule. Okay, so here is the capsule all alone because we're about to re-enter. So here, we are now in atmosphere, and you're going to notice that the capsule will be subject to aerodynamic forces, and of course the friction from hitting the atmosphere at this speed, which is around 2,321 meters per second. And you will see flames when we hit around 40,000 meters. Here it is. Re-entry flames. We're like a meteor. Look at Valentina, she's smiling. Maybe she's happy that she's about to go back home. We can check, look at the ablator, or the material that is actually being burned up, that's absorbing all the heat, is actually being depleted, but it's still quite thick. Look, it's just eating up something like maybe 10% of the material, so we're quite safe. We're not heating up. And I think, we're not going to land anywhere close to the Kerbal Space Center. I think we're going to land somewhere over here in this part of Kerbin. I don't think we're going to land on the water, which is fine. In the American space program, they preferred that the capsule landed on water. For one reason is the fact that water can actually absorb the impact of the capsule better. Maybe it's more survivable than actually having to land the capsule on solid land. So we're slowing down now, so you can see the re-entry flames are disappearing. Okay. Valentina has stopped being excited. She's now maybe slightly worried. She's wondering if her parachute will actually open up. And actually, I'm not sure if we're going to land on the water. Maybe we'll land on solid ground. Well, we will find out. I can speed up time a bit. What is your bet? Is it going to land on that island or on the water? It's gonna land on water. It's clear. One thing about accelerating time though is because of the fact that when you accelerate Kerbal, it's going to do the time slices in such a way that the physics won't be that accurate compared to like you're doing it in real time. That's the problem sometimes with accelerating time. So as much as possible you avoid that. Okay, 1000. I'm going to release the parachute now. And just in time for it to open. We're just a few meters from the ground. I'm about to end my session, so I hope you enjoyed that short Kerbal Space Program intro, because I haven't really done a proper intro to Kerbal Space Program by this simple, it's actually, we did a full mission. It's orbiting the Earth and actually coming back down into the Earth. But I really wanted to land Valentina on the Space Center, but fortunately, we did not do any proper calculation. You can actually calculate that if you really want the capsule to land on the actual Kennedy, I mean, I keep saying Kennedy Space Center, the Kerbal Space Center. And here's splashdown! And Valentina is so happy, and we can recover her vessel. And that ends this Kerbal Space Program session. I hope you learned something about the program itself and how educational it can be. I'm going to do more of this soon so that I can actually encourage teachers. If you're a teacher and you are computer savvy and you want to invest time and resources in using Kerbal for teaching physics and other natural science concepts, well, I hope I can help by these videos, these tutorial videos. And maybe in one of these sessions, magsasalita ako or gagamitin ko is the vernacular. Para naman yung yung iba na medyo naiilang kasi English ako ng English is mas comfortable learning about KSP using Filipino. Okay, so goodbye and thank you for watching this session.